In this lecture, we are going to get a brief overview of Webpack. Throughout this section, we've dedicated our time to learning about Vite. Vite is going to be our primary choice of a module bundler. However, you may encounter Webpack during your career as a developer. This lecture will give a quick overview of what Webpack is and how it works. In the resource section of this lecture, I provide a zip file. Download this file, unzip the contents, and point your editor to the directory with the files. I recommend uploading these files to an empty directory. Pause the video if you need. Once you're ready, let's try installing the dependencies. Open the command line. Let's run the npm install command. While the packages are being installed, let's explore the files. The script and CSS files are copies of the files from the Vite project. The project I've provided will output the same behavior as the previous project. However, these files are bundled with Webpack instead of Vite. Let's open the webpack.config.js file. Unlike the Vite configuration file, there are dozens of lines of code. Webpack is more hands-on than Vite. As far as Webpack is concerned, only JavaScript code is supported. Support for other languages like CSS or Sass is not supported. Every tool must be configured in the bundling process. For this reason, Webpack has a higher learning curve. To save time, I've provided the configuration code for you. Let's review it together. During the bundling process, Webpack will search for this file. If this file exists in our project, it'll apply the settings exported by the file. There are 4 properties that can be configured. The first property is the entry point. Previously, Vite configured the entry point as the HTML file. For Webpack, we must set the entry point to a JavaScript file. The entry property allows us to specify the entry point of our application. In this example, we're passing in a relative path to the index.js file. Up next, we have a property called output. In addition to setting the entry point, we must tell Webpack where to save the bundle. In this object, there are 2 properties called path and file name. The path property should point to the directory. The value must be a full system path. To help us generate a full path, we're using a constant called directory name to point to the current project directory. This constant is defined by node. Afterward, we're appending a relative directory called distribution. This directory doesn't exist, but that's okay. Webpack will create it for us during the building process. As for the file name property, we can set the name of the file produced by Webpack. In this example, we're setting the name to bundle.js. Let's move on to the modules.rules property. As I mentioned before, Webpack supports JavaScript. Other languages or file types are not supported. We must add explicit support for other types of files. Loaders are packages that will help us support different files. In this example, we're adding support for 2 types of files, JavaScript and CSS. Each object in this array can represent a file type. In the first object, we're adding support for JavaScript. Hold on a moment. Didn't I say Webpack supported JavaScript? Well, that's true. The support may be lackluster. New versions of JavaScript are released annually. You may want to start using newer features from the language. However, these features may not be available in the browser. There's a package called Babel. This package adds support for new and experimental features in JavaScript. Oftentimes, developers will integrate Babel with Webpack. This is why I've included this object. This object has 3 properties. The first property is called test. Before a file is given to a tool, Webpack will test the file name against this property. Babel does not process CSS or image files. To avoid Babel from processing the wrong file, we can test the file name. The value for this property is a regular expression. It'll check the name for a JS extension. If this extension exists on the file, Babel will process the code. Up next, we have a property called exclude. It's not uncommon to import code from packages in the Node Modules directory into our project. There are thousands of files within this directory. To speed up the bundling process, we'll skip files in this directory. They should already be optimized for the browser or Node. Lastly, we have a property called use. This property can be set to the name of the package that contains a loader for processing a file. In this case, we're using the Babel loader package to process JavaScript code. Let's scroll to the second object. The properties are going to be similar. The second object is testing for a SAS file. There is no exclude property. It's completely optional to add it in. Lastly, the use property is set to an array. We're not forced to apply a single loader. We can apply multiple loaders. In this example, we're applying loaders for SAS, CSS, and post-CSS. There is an additional loader called mini-CSS. By default, Webpack will bundle our CSS and JavaScript into a single file. However, that's not ideal. We may want to separate both languages into their respective files. The mini-CSS loader will handle extracting CSS from a JavaScript file. This loader can be configured through a plugin. Below the modules object, we have an array called plugins. Within this array, we can add plugins for extending Webpack with additional behavior. In this example, the mini-CSS package is being configured by setting the file name of the CSS file. The last setting in our file is the watch property. By default, Webpack will build your project once. However, you may want Webpack to constantly watch your files for changes. Setting the watch property to true will enable this behavior. I know I flew through the configuration. This lecture was meant to give an overview. We're not going to be using Webpack. I included this lecture for those of you who are curious as to what the hype is about for Webpack. Let's try running Webpack. In the command line, run the following command: npm run start. In a few seconds, Webpack will watch our project. We can update our code for a new bundle to be produced. The bundle will be created in the distribution directory. If we look inside this directory, we're going to find the JavaScript and CSS code. There are some things missing from the Vite project. For example, an HTML file is not available. We don't have a server for previewing a project. It is possible to generate a server, but I wanted to keep this lecture brief. For that reason, I only included support for JavaScript and CSS files. In addition, ESLint is not checking the quality of our code. Webpack can support additional tools. Feel free to add support for these features. Anyway, that about does it. In the next lecture, let's wrap things up. I'll see you there.